Hello, welcome to a new episode of our Share Green Design podcast. Today, our guest is Kjell Anderson from LMN Architects in Seattle, in the US. So, Kjell is an architect and principal at the practice, but he has a long list of hats he wears. So, I will just mention the two or three main ones, and you can check his LinkedIn profile, or when we post it, you can check the website for a more thorough description. But he wrote the book Design Energy Simulation for Architects in 2014, and he serves currently on the Washington State Building Code Council, where he chairs the Energy Code Technical Advisory Group. He also co-authored the AIA's first policy statement on climate change, and he's been working on the sustainability side or sustainability front and design and architecture for 20 years. So I think with that, Chair, we would like to know. I think the first question for you would be, how did you get interested in sustainable design? Where that interest came from, and when?
Yeah, it's a good question. It's an origin story, and I don't really know it, where it all came from. But probably the first time I really thought about it was I was in college at Washington State University, and I could tell that there were books on good design, good thoughtful design, aesthetic design. There were books on good detailing. There were good books on everything to do with architecture, but there were very few books that were practical about sustainable design. It seemed like this missing area in the whole practice of architecture. And the further I got in university and the further I got in the profession, the more I realized, we can have a long conversation about detailing or design or many other aspects of programming of architecture. But it was hard to have a long conversation that had a practical means to it for sustainability. And there's this big missing area. There was the passive handbooks, from the 70s, but that didn't apply necessarily in Seattle or many other places. And there was, discussions and debates on whether passive house was a good choice or not, as far as, the embodied carbon of insulation versus energy use. And it just seemed we didn't know much about it. And as a young practitioner in the early aughts, I wanted to explore new areas and exciting areas, and so it just called to me. And then also, I think the kind of environmental ethos just was part of how I was raised and who I wanted to be as well. So conservation ethic, etc.
Hmm. Yeah, that's good to know. And I kind of thought that it would come that way, because I think it links also with the work you've done recently, which we'll talk about later, because the documents you have prepared or you've led on the preparation, and the amount of information that's there, and also I think it's with that mindset behind this, because even though you are talking about probably 20 years ago, when that information was available, we haven't moved much since, and that's why I guess you felt the need of preparing those documents to share that knowledge. So
Yeah, I think we've moved a good deal since then, but
yeah,
we're still at the beginning trajectory of where we're going, I think.
yeah, and so if we go back in time, in 2014, the book I mentioned earlier, that was a design energy simulation for architects. So we'll have a link to the book when we publish it on our website. So in that case, the focus was more on the energy use of buildings. And
Mhm.
so you, at that point, you were already sharing that knowledge and the case studies that you work on, but there wasn't much on embodied carbon. So anyway, we'll touch on embodied carbon later. So on that energy simulation, could you tell us about that and the work you did and the book itself, and what was your thinking at that time?
Yeah, it's interesting. It grew out of a lot of other things, and the short of it is, in 2011, I spoke at Greenbuild about an energy modeling program that I had started at Callison, and a publisher actually came up to me after the talk. The longer version is, in about '07 or '08, I learned how to use Ecotech software, and that was the first time I was able to put numbers to sustainable design practice in terms of energy performance. And so that was really exciting to me because I like to quantify things. And I like to say, well, am I really doing better than this? And at the time, I was working on projects in India, and I was drawing these natural ventilation arrows. And I think most architects have drawn natural ventilation arrows at some point. But I think in almost every case, you have no idea where the wind is actually going to go. Right? You couldn't really say the wind should do this,
Yeah.
and the wind doesn't know that you're telling it to do this. So you might have some general principles, but you don't really have a great notion of that you're doing is physically correct in terms of physics.
Mm.
And it brought a bunch of questions in my mind. Well, am I doing my passive design right? Am I doing the quantity of insulation? Am I doing all these things correct or not? And Ecotech helped me start answering those questions about solar gain on which facades, and it brought up a lot of unexpected insights into design that I hadn't considered before. And so from out of that learning Ecotech, I was so excited by it. I worked on a group to the Seattle Ecotech group, user group that shared how to do modeling, and we brought in some engineers that actually did real modeling, and we just did kind of architect simple modeling with solar and shadows and a little bit of shoebox modeling. We brought in those people, and so we had a monthly forum on that, and then I wrote a letter to the group of people that ran Callison and said, I think we should do this on every project. And I didn't expect it to go anywhere, but in fact, they said, sure, why don't you lead it? And so I prepared about a 40-hour training course for people, and I presented that in Seattle, in Shanghai, in Dallas, and LA to train people. And then I ran a program where most major projects that we worked on for a few years used some sort of simulation, and the people I had trained did that simulation on the projects while I oversaw it all and QA'd it all. And finally, I got to I wrote a session for Green Build for 2011 and was accepted and spoke on it. I put every ounce of energy I had into physical energy I had into that talk, and out of it, I got a book deal.
Mm-hmm.
Which was really exciting. And I told my wife, I said, well, someone wants me to write a book, and I don't know that I can do that. I'm working full time as an architect. I have a
Yeah.
lot of things. Um, uh, we had a kid at the time. We were about to have kid number 2, and she encouraged me to do that. So the first 4 months of kid number 2's life, Lena, I was writing a book 12 to 14 hours a day, and my wife was taking care of the 2 kids, and neither of us was working. She took time off with the kids, and I took time off to write the book. So it was a really intense thing. But yeah, the book has all the best. It's organized so that you have, it's about half case studies. So we wanted 30 or so case studies in the book so that you'd see, and it was more of a menu, because what I found at Callison was when I went to a project manager and said, hey, we should model some things, they wanted a menu. Well, what does it look like? What are you actually modeling? And it started to unpack the idea that energy modeling is not one thing. It's a question and answer. It's asking, well, what would happen if we did this? What would happen if we did this? Would my energy use go down if I did this? What is the right window design for this building? Which are not coming up with an energy use intensity necessarily. They're coming up with just a hypothesis and then a series of options and then an answer based on that. So it's more of a series of inquiry than it is kind of one thing where you say, do an energy model. It's like going into a restaurant and saying, I want food. Like it's not going to get you what you want.
Yeah, no, I guess it's playing around and finding what the different options will give you and learning from those options and then implementing that in the design of that particular building or in future buildings, I guess.
Yeah. It's how could you use energy modeling to improve your building?
Yeah.
And what are 30 different flavors of energy modeling?
Mhm. And
And
how did, because that's energy modeling, when did embodied carbon coming to the game as well. When did you become aware of the embodied carbon, and then it made everything more difficult as well, because it wasn't only about the energy savings, but also what was the impact, as you said earlier, with passive house design, and
Yeah.
that you have to be mindful of the overall picture.
Yeah, it was floating out there for a while, but I didn't like until Tally came out, which is Kieran Timberlake came up with that.
Hmm.
Until Tally came out, I really did not know how to quantify it or how to use it. I had experimented with bees and Athena a little bit, but not really gotten into. It didn't seem like it was ready for prime time for me to use. But there's a couple. It was floating out there in interesting ways. The Living Building Challenge was published in maybe '06, and I was reading Walden by Thoreau at the time, and it was fascinating because he describes actually in the book how he came across the wood and the nails and everything that goes into his cabin in the woods. He talks about his energy source. It's almost like he wanted to, 100 years later, 150, 100 some years later, get his cabin to be LBC certified. So I actually started going through the documentation for his cabin, Thoreau's cabin, for LBC certification to try and get to know the system.
Hmm.
I didn't end up submitting it. I thought, that'd be a little cheeky maybe to submit it. But he's quite specific about everything he gets in there, and it's almost as if he was anticipating that.
It was
And that started getting me into
an
like,
inventory for a life cycle assessment.
what was
I
that?
mean, that it was an inventory for a life cycle assessment.
Yeah. He kind of characterized where he got everything for the building. It was kind of fascinating. Then the lead credit for transportation distance. I worked on a project in Hawaii, and it made no sense. You couldn't get everything within 500 miles of Hawaii, really, unless it's manufactured there. So then I started doing takeoffs of like ocean freighter versus truck versus train, and realized that from a carbon perspective, you could get stuff from 150 miles inland of the U.S. Or 150 miles inland of parts of China, and it would be the same carbon transportation distance as the 500-mile radius in the lead credit if you used a truck. So that was a little introduction to A4 of embodied carbon. And then in 2016, working at LMN, Brad Binke, who's now at the Carbon Leadership Forum, wanted to get Tally to explore embodied carbon. And I said, yeah, let's go for it. He did a great study called Whose Wall Wins, which compared 10 envelope embodied carbon from GWPs from projects we had actually completed. So we knew how it was constructed. We knew all the little bits, the screws, the standoff clips, and all that went into it. So we did a very detailed analysis, and it was very eye-opening. And since then, we've done embodied carbon analysis on many projects. And since about 2019, we've done embodied carbon analysis on every project.
Mhm.
And then along with that is reductions.
Exactly. So it's the embodied carbon analysis reductions, but you continue doing the energy modeling as well. So then you have that overview. Could you tell us about that holistic view on the embodied carbon and the energy modeling and the results and the learnings from that?
Yeah. Energy modeling is a very different thing than embodied carbon modeling. And for a variety of reasons. So when I got to LMN, I thought we were going to do energy modeling on every building in-house, because that's what I wrote my book primarily to help architects do in-house energy modeling. But I realized that LMN tends to do larger, medium to larger projects where we have uh, very complicated buildings that don't behave according to normal schedules or normal ways of doing energy modeling. So we do energy modeling on every project, but we have a third party do that on every project. Sometimes we do in-house daylight and solar analysis on projects, but we do full energy analysis and early energy analysis on our projects using a third party, and that's actually, I think, probably a good model for medium to large projects, because there's people out there that are just so good at energy
Yeah.
modeling. You can do it in a lot less time, and they can get everything right. Whereas architects are, it takes a lot of training for an architect to do correct energy modeling other than solar and shading and maybe a couple other things.
Yeah, but it's important what you said earlier. It's about bringing them early in the journey as well, so you can
Yeah.
incorporate those learnings into your design. And I guess, and then when do you start working on assessing the carbon impact of some of those decisions?
Yeah, the carbon impact of the energy decisions,
Yeah, sorry, the embodied carbon impact. So
the embodied carbon
once you
impact.
have,
Yeah.
yeah, the embodied carbon, yeah.
So we in the Path to Zero we have a long list of structural things we do on the projects, and it goes from the earliest conception of the building to procurement and construction in the end. And it's usually we don't get a full model until middle of design development. So, maybe about 2/3 of the way through the design of the project is when we finally get a robust model that has all the steel in it. It has a modifier for fireproofing. It has a concrete. We use multipliers for rebar usually. And then it has all the drywall, the studs, the carpet, all of these things in it. Finally, we can do a detailed analysis.
Hmm.
We do early analysis. Well, we do. I'm a big fan of doing analysis to make decisions so that we can make better decisions. So at that point, we can make decisions about what are the biggest impact and what's going to do the best thing we can with, should we focus on the drywall? Should we focus on the ceilings? Can we dematerialize things? But a lot of decisions have been made by then. Can we research more, different material for things? Um, for earlier in the project, we make mass timber decisions early because mass timber is generally an embodied carbon win, but it has to be done in schematic design or concept design. And so we're working towards that, and we can come up with early quantification of the savings from that, but it's not from a full life cycle assessment. It's from an early model using like EC3 or OneClick or something like that.
Hmm. Okay.
Um,
Yeah, I think I like what you said about the analysis to make decisions, because I think that's the key. If we do a lot of analysis and calculations, and that's just for the sake of the calculation itself, that's okay. It's fine for a database, but the key is that that's implemented in the design. So, and what I would like to ask you as well, and for those that don't know you or your work or LMM, the reason we invited you for the podcast is the Path to Zero Carbon series that you publish, or you have been publishing for the last 5 6 months. Is that, would that be
it's
right, or at
actually,
least that's when I learned about it?
yeah, it's been going on for a couple of years.
Okay.
But I've really started on LinkedIn posts the last 5 or 6 months.
Okay, so that's when we learn about it. We publish a couple of them in our website in Zero Green Design. But then the other thing that was a bit surprising as well is that you're an architectural practice, as you said earlier. So I've seen similar documents, but not to that level of detail from NGOs and foundations. But in your case, it's a private practice. So when or how did you decide, or your colleagues in your company, to make all this research, because there is a lot of work behind it, to make it public, open source for anyone to read it and learn it? Because you could have hold it as your your unique, or your unique selling point, or your thing, but you decided to make it open and share it with everybody.
Yeah, yeah. I mean, it's a good question because it's a lot of work, a lot of investment in it. I guess the private industry has more latitude to fail forward and to be speedy about things. When we were thinking about this a couple of years ago, one of the issues is if we try to convene a group to convene another group to get all the right stakeholders, like everyone who knows anything about embodied carbon to weigh in on embodied carbon, everything who knows anything about climate change to weigh in on the climate change post, it would have taken years and years and years, and we wouldn't even have been guaranteed success. If we were an NGO, we would have been criticized perhaps for not inviting absolutely everybody to the table for that kind of conversation. Instead, we were able to basically just say we're going to do what we want to do to write a directionally accurate set of posts about these things. We'll be a little bit wrong about some things. We won't include every single one of the best links, uh, but we have the advantages of, as private industry, we do this on every project. We know how things work. We know what works. We know what doesn't work. We're not going to. I think I've seen some some similar things by NGOs where they spend a lot of language on things that don't work, and we knew we could avoid those kinds of pitfalls on this project. And NGOs and governments, they care how they're perceived in certain ways, and the private industry has different perceptions about how we are seen in the marketplace. So we were able to be kind of in the fail forward mentality the whole time, and then reach out to people that we know that are experts in this, and then use that for more connections to get more experts on this. So each one of them had many reviewers on it. But I think the private industry side is, we're just able to go quicker if we want to get something done.
Okay.
The reasons why we did this, since you kind of asked that as another, there were really about 5 reasons why we did it. One, we were updating our sustainability action plan. In 2018, we said we want to have a goal. We listed about 50 goals we had and process improvements. And one of them was like, we want a 1 net zero, project. And we have a dozen of them now. So we obviously needed to set higher goals. We're also, we're really getting really close to the year 2030, where we've pledged, and most of our other, architecture peers have pledged to design only net zero buildings, according to the 2030 challenge and 2030 commitment. So we needed to update our sustainable action plan. That's reason one. Number two, there's times in history where people kind of know what they need to do and they just need to do it better. And there's times when there's rabbit holes everywhere and they're deep, and nobody has time to go down in every single one of them and figure out what's going on in those deep areas of research. And as architects, we're coordinators and we're aware of those deep areas of research. So we were able to go in, find out the information, and then pull it out to a to a more general audience, take the deep areas of research and extract it a little bit. What's actionable now, like 99% of architects, I, as a full-time director of sustainable design, am kind of drowning in resources. There's so many resources out there for me to use to design zero carbon buildings, but there's too many of them to really understand any of them. I can read a few maybe, but 99% of architects don't have time to read any white papers on zero carbon buildings, or maybe one. So how do we create a resource that has only the most actionable things and none of the fluff in it, and so that we can begin to talk about carbon instead of just energy when we're talking about projects? And I think that's maybe the third big piece is we're going from a time of talking about energy use as a proxy for carbon emissions to actually talking about carbon emissions. For a while, embodied carbon was called embodied energy because it was quantified only as how much energy was used. And then it became embodied carbon because we're making this transition right now. And I would say most architects are uncomfortable now talking directly about carbon in a comprehensive way with our clients. And so this is a way to help the industry transition from talking about just energy use reductions, to energy and carbon at the same time. Number 4, there's lots of claims in the marketplace. We see that often. We see zero carbon hotels or office buildings being claimed. And we all know, including the people making the claims, that they're not true. And it's really frustrating because it's, if I say I'm going to rake all the leaves in the yard, I tell my wife, hey, I'm going to rake all the leaves in the yard, and I rake a quarter of them, it's really obvious that I did not rake all the leaves in the yard. She's going to say, well, you didn't rake all the leaves in the yard. Whereas people are getting 25% of the way to zero carbon and then saying, we got there, woohoo, we made it. And it's crowding out all the real work that's going on to get, 10% of the way there, 15% of the way there, 20% of the way there. It's crowding out all the hard work when you have those questionable claims. And then the last reason is nobody can get there until we all get there. We need better products on the market. We need zero carbon interiors products. We need zero carbon structural products. We need zero carbon MEP products. All that stuff needs to be there. And we need to have a 100% renewable grid to actually get there. The things are clear to move forward. So we all need to work to get there. And it's so that's what it is. It's intended to be a collaborative piece to help everybody get towards zero carbon, or at least know that we're not at zero carbon and we have a long way to go to get there.
Mhm. I think one of the reasons as well is perhaps we are using the wrong terminology, or we are not, or we are not using in the right place. Because when we talk about net zero and carbon neutral, it's, if you take it by its meaning, it's net zero, but we know it's not. So, and that is forcing to other things like. So if we know something is not that, like but this is more a question, okay? It's not, I don't want to say what I think, but do you think we should continue using terms like net zero, carbon neutral, whilst we are still finding our way on that, or should we use different terminology?
That's a really good question, and I don't have a great answer for that. I think carbon neutrality is the goal as a society, as a world society. I think carbon offsets are really a challenging thing because they can make you think you're carbon neutral, but many offsets are not doing what they claim to do, and we have a whole post on that one.
Yeah,
I don't
but
know what the right
sorry.
terminology is. Yeah, I don't know. Do you have a preference for the
No, I
term?
think it's, my thinking is that perhaps we are dedicating too much effort because we've set up the target on carbon zero, or whatever we want to call it, but we know we are not there. Then we are putting a lot of effort to find a way to justify that we are there. Call it carbon offset, or whatever we want to call it.
Mhm.
I think it would be better to acknowledge where we are, and, and where we want to go, rather than pretending that we are here already, because we are not. And for people outside of, because that when you read net zero, there is something behind. It's not that the building has zero emissions, but
Mhm.
for other people outside of the industry, they might think that that's the case, and it's wrong. I think it's sending the wrong
Yeah.
message. But anyway, this is my opinion. It's not. Anyway, but I think it's. I like, there is one of the episodes in your series is about that, and I like the way it's explained. So anyway, it's a really good document. Well, sorry, it's a very good series of documents. So I recommend everybody to read it. What you said about removing, I like also that is, even though you touch on a lot of topics, it's a really good summary. I don't know how many pages per document, but it's not like 100 pages. I've seen documents that touch on less information and they need 100 pages, sorry, to tell that story. And you give
Mhm.
in these documents, you give much more in less, which I know is also more difficult because you need to condense all that knowledge into less. But I think that's the beauty of that document. That's why we are talking about it today. So you're also talking that about the role of the designers
Mhm.
in all this, and I fully agree with that, because for a long time, and I think it's still happening, we design something and then we go to a construction company, or we go to the market and ask for something that makes our buildings again carbon neutral. But there is a lot of responsibility on the design side. So how is your work with with other architects, engineers, quantity surveyors? How is that working environment? Is it a collaborative environment, or do you need to push on your side to get the outcome that your client also set up, or how does that work?
Yeah, I would say I think finally in the last 3 or 4 years, most people in our industry are on board with doing something about climate action. So I think the first conversation is it necessary, is has happened, and we're generally there. Then the next question about, well, what is standard practice and what do I know how to do and what do I not know how to do? Then that's where we get the technical challenges of stuff not happening. Is if somebody's uncomfortable, maybe they're a concrete supplier and they've never tried to get 30% substitute cementitious materials into their concrete and supply it. Well, now they have a technical challenge, so they're on board, maybe ideologically, or maybe they understand, um, but they're uncomfortable with doing that. So then it's about getting technical knowledge in people's hands so they can actually do these things. And I think our industry is pretty collaborative at this point, as far as sharing knowledge and as far as trying to work together. I think 20 years ago it was more adversarial between architects and contractors, but now we have, most of our projects were partnered with or we choose to partner with a contractor. And so they're trying to get a good outcome where the client's happy, and we're trying to get a good outcome where the client's happy.
Hmm.
And many of our clients have carbon goals of some sort. So if we can meet those, great. If we can exceed those, even better. So we don't have to worry about that, the collaboration quite as much, but there's still, we work around the country. Um, and there's just different levels of knowledge and different products available in different parts.
Hmm.
Like we were talking about embodied carbon on a project in University of Wisconsin, Madison, and type 1L cement, which is a lower carbon cement, is just what everybody in Wisconsin does now. The state has moved towards that. That's what they're doing in many states, but it's great to just see that happen. And then we go there and already we're getting a 10 or 15% reduction in our cement usage because of it.
Hmm. Yeah, and that now that you mentioned cement and concrete earlier, that links to the concrete zero. We know there isn't a zero concrete. There could be lower carbon, or we can call it, but it's not zero. And the same happens with steel and other materials. So in your book, you talk about materials, but there is a special focus. There is one chapter that's about steel, concrete, and wood.
Mm-hmm.
So, and you refer there that concrete and steel use accounts for roughly 21% of the global carbon pollution, it's called. And then about half of that is the built environment. So that's a huge, only those two materials is a huge issue. So how is your plan, how you work with that, or how you work having all that into account? Because when you use concrete and you use steel, it's going to have an impact. So
Mm-hmm.
what is your approach when working with those materials?
Yeah, well, that's a big question. The Carbon Leadership Forum kind of had those stats available on the 21%. And there's a group called the SE 2050, Structural Engineers 2050, that's working on those things. And this is one of those, going back to the society issue, is how do we get zero carbon steel on the market? And there's a low carbon steel market buyers association or something like that that is already procuring 2 million tons of zero carbon steel and trying to spur a market for it. So none of our projects are going to do it by themselves, but if there is a demand, there are amazing people right now in manufacturing that are racing to get zero carbon cement and zero carbon steel. And we can get very low carbon steel with recycled steel, using electricity that's 100% renewable in that steel, and then capturing what comes out of a stack if you're doing that, the impurities in the steel. And that's happening right now. It's great to see on so many products that we use as architects. There's lower carbon drywall, there's lower carbon metal studs, EQ studs. There's, you name it, somebody's working
Hmm.
on lower carbon carpet. When we did a remodel in 2014, carpet was a quarter of the entire embodied carbon of our remodel of our office. And now there's zero carbon carpet on the market, or roughly carbon neutral carpet on the market. So there's, but we can demand it and we can ask for industry guidance. But as far as the products, we all need to get there in order to get there. About steel, concrete, and wood, those are, the structure is a bit simple because there's really only about three major materials that are used on there. Now there's varieties of concrete and varieties of steel and varieties of wood. But it's an early decision on projects, which structural system you use, and then beyond that, it becomes a procurement decision for steel. Which bids are you getting in, and what is the carbon impact of those steel products? We have in the number on the structural path to zero carbon, we have a long list of things to do at various phases as well, and they involve things like you can specify lower carbon concrete and you can put that in the specs, and that's what we have on every project now. You can have baselines for those products. You can, of course, designing less transfer beams is a big
Hmm.
embodied carbon win. You can dematerialize a project. Do you really need to build um, something that you're considering building? If you don't build it, it's a lot less embodied carbon. Can you renovate a building That's
Yeah.
how, that's the major structural savings you can get. So we have a different one on existing buildings and then another one on circular economy.
Mm.
And when you,
And yeah,
yeah,
sorry, go.
no, and when you get to really low carbon materials, you are in the circular economy,
Yeah.
because taking something out of the ground, using it for 5 or 10 or 15 years after manufacture, and then putting it in the landfill is not ever going to get to a zero carbon economy, and it's got other environmental problems as well.
Mm. And that's what I was going to actually when I interrupted you earlier, because it's that link between carbon reduction and circular economy. But then the benefits of the circular economy is not only the carbon, is many other environmental factors that you pointed out, but it's also the resources. Because there is a scarcity of resource, and if we keep just dragging it, and taking more and more resources to build new materials, there is a
Yeah.
limit to that as well. So it addresses both issues. So how are you, or it's your practice, or in the US, how is that working on the circular economy to implement, to reuse materials, for example? Is that something that is done? Have you done that on some projects?
Yeah, it's really hard though. It's another thing where the industry needs to be better before it's easy to do. But we did a renovation for Heinz, and we set a goal of doing zero carbon or carbon neutral or something like that on the project without offsets. And so that meant every product we got needed to be from either a zero carbon product or be salvaged or recycled, or not even recycled because that takes some carbon as well. And of course, we didn't get there. Right? It's just not possible necessarily to get there right now. But we uncovered a lot of things while doing it. One of the great examples is originally the carpet was, we didn't like the carpet. We didn't love the carpet, let's say. Um, but but it had years of life left in it. It was not, soiled and disgusting. Uh, it was actually in decent condition. So what we did is we started crafting a material palette around the existing carpet rather than ripping it out. The normal thing to do would be rip it out and come up with a new material palette, build all new stuff. It was carpet. We applied that ethos really thoroughly over the whole project. We ended up finding, relights that were uh, needed to go because we were removing an office or something like that or renovating it. But we found a different place on the project for that relight. We looked at refurbishing the doors instead of buying new doors, and that was actually cost prohibitive. So we ended up just leaving the doors, and they're maybe a slightly different tint than we would have chosen new, but they're not that different. We removed the ceiling. There was no need for the ceiling. We bagged up the ceiling tiles and we sent them to another project. We took all the acoustic insulation that we demoed and we sent that to flood victim housing. So there's this really ethos that got us reusing materials, getting salvaged materials. We also found a warehouse full of brand new carpet that had never been used that was going to go to the landfill. And we were able to use that carpet to fill in a couple of areas as well. So by rethinking the project around the existing materials and existing space, we ended up with a project that you would never know had that aesthetic applied to it necessarily. It looks like a brand new, gorgeous project. It is, but a lot of the stuff is not new, it's salvaged. And
But
there's
that
some
requires much more work on your side as well, and research from
it does.
your company and the contractor, I guess, as well, and whoever, and the client, because he's, I guess, the client, or you have to change some of your designs to accommodate for that, and the client has to accept it as well. So it makes the whole process a bit longer, I guess, or at least more intense.
It does. It takes more work. It takes more work to kind of think about salvaging, think about using salvage materials and all that. There's a couple of marketplaces set up, like Doors Unhinged has doors where you can buy a bunch of doors that are salvaged and get them installed on your place. There's a couple of material marketplaces that exist. Reaply has one or a few that they're trying to run nationally, where you can buy salvage materials. And then there's architectural salvage in lots of places where you can get older things, but places where you can get refurbished materials, that's just something that needs to happen with the economy of, yeah.
And do you see that happening more and more? locally, I mean, or in the US, or you think it's a steady growth, or you think it's going to grow more exponentially?
Yeah, I think something you said earlier about the extractive, mining for things. You mine for the easy stuff first, and after a while, it just gets harder and harder, and more expensive. Right now, it's still cheaper to mine something and landfill it and mine something more
Yeah,
than it is. But we're seeing like King County, where I live, has ordinances at the landfills. San Francisco has ordinances, and we're starting to see, and Austin has a deconstruction ordinances and policies where instead of just chucking everything in the landfill and covering it over, um, you actually have to salvage things. You have to use them beneficially. And there's an interesting thing in our industry where um, we talk about materials uh, that don't go to the landfill. We use it diverted. We say materials are diverted from the landfill. Well, that doesn't necessarily mean they're used again or
mm,
refurbished.
yeah,
It just means that they weren't, and they maybe end up in the landfill. A diverted material might end up in the landfill. It just had something else happen to it before it went in the landfill.
mhm,
So
yeah,
we need to get to not diversion. We're proposing a metric where you also disclose diverted, but then you also disclose the reused or salvaged portion
yeah.
of, yeah.
Definitely, that's an important part. And going back to the net zero, carbon neutral, I, I think without that circular economy piece, it's going to be very difficult. It's keeping the materials as much as possible in the loop, and that's why how I think it could be achieved. But the other part is, yeah, you touch on that as well on that project that you work is reusing the entire building. So how is it in your experience? Do you have more clients asking for new projects, whether it's on a brownfield or demolishing and building a new building, or is the reusing buildings becoming more the norm in your experience?
Yeah. So for the first time last year, over half of architectural billings, how much money we made as a profession, were for reused buildings. That includes TIs, but also renovations of buildings of various kinds, massive renovations to, tiny renovations. So that's heartening.
Yeah.
Um, when the clients come to us, usually they've already made a decision. We have, in some cases, the ability to help change their mind, but often, like with a university, often most universities in the United States have deferred maintenance, which means they have not had the money to maintain buildings for the last 50 or 60 years. And now the deferred maintenance backlog is so much that renovating the building is really not even a possibility.
Hmm.
We also there's a period of time in the 60s and 70s and 80s where a lot of buildings were built very inexpensively and have low floor to floor heights. So they really can't be used for much. If you have an 8.5 foot floor to floor and you have 7'6" ceilings, you can use that maybe for residential, but you can't really use it for much else.
Hmm.
We've seen a lot of buildings like that built in the 60s and 70s and 80s, unfortunately. And those, sadly, you can deconstruct them, but you can't
Yeah.
really reuse them for much.
Yes. And what about the impact? Because we've been talking a lot about, not a lot, but all this time we've been talking about buildings and the impact and the embodied carbon and the operational carbon or energy modeling. What about the infrastructure and before infrastructure? What about planning and the implications of planning decisions into the carbon emissions of the buildings and the related carbon emissions to the infrastructure that has to be built to connect those buildings? Are
Right.
you working on that as well?
Yeah, that's a really unknown. There's parts of the series and parts of things that are well known, like structure and embodied carbon. The infrastructure part is very very little known, and the transportation side of it and all that. There's only a few studies, and I'm almost done with post 16, which is the last one in the series, which is on all of that stuff outside. There's two tools that I'm aware of that do landscape and site carbon emissions. One is Carbon Conscience, and the other is Pathfinder.
Hmm.
Those are coming out in number 16. As far as the infrastructure, obviously, a bunch of single family houses that are 100 feet door to door, have a lot more infrastructure in the ground to get sewer and electricity and all that to the houses than a dense high-rise apartment. It seems like there's a sweet spot in the 3 to 5 to 7 story buildings with embodied carbon, where if they're taller than that, they have more embodied carbon and
Mhm.
possibly more total carbon, including transportation, elevatoring, and all that. And then obviously, single family houses is not the most carbon smart planning move. But like in Seattle, we have the issue where 70% of the land that's not roads is zoned only for single family housing.
Mhm. Yeah.
So unlike many other cities, we just can't build the 5 story buildings that would allow us to reduce carbon emissions of the whole society.
And that's a really good point, because then no matter how well you do your single house and how low the carbon is for it, it's all the other implications, isn't it,
Yeah,
associated with that, but which is something outside of your control as an architect or designer.
yeah. It's kind of outside of our control, but we also, architects make good policymakers because we're a good balance of private industry and pragmatic things with
Mhm.
having vision of the future. So a lot of architects are involved in policy and helping set those regulations. And in fact, in the state of Washington, a bill passed that said every every single family lot in the state is now can accommodate 2 families, and most of them near transit can now accommodate at least four, have to accommodate at least 4 units. So now every single family lot in Seattle is, most of them are probably going to be able to accommodate four units on them. So that's a step in the right direction.
Yeah. See, what I mean is that if that's not done at policy level, then when it arrives to a designer, then it's too
Yeah.
late. That's what I mean. Is that has to be done one step before. So
Yeah.
that is, but it's good to hear all those things happening as well. So the other one is the, yeah, we talk about the yeah, it's density. You talk about the sweet spot between 3 7. There is a very good research report just published a couple of days ago, 3 days ago in Ireland. Uh, by it was developed by UCD, University College Dublin, and the Irish Green Building Council, and they talk about this thing. So I will send it to you because it's about that. They've done some calculations. It's a document again I like because I think it's 10 pages, 15 maximum,
Mm.
and they've compared terrace housing with 3 stories, 4 stories. What if you park in one way or you park in another way, and what are the carbon reductions associated with it? So it's very simple, but I think it gives you a good idea of what of the the huge impact that it has. So it has to be developed further, and they will continue doing it. But I think it's a good start. So I will share
That's
that with
great.
you. And
That's
then I
great.
think,
Yeah.
yeah, and as I said earlier, the your series, it's 16 documents, and there is another one that's coming called the Path Forward, which I'm looking forward to read. Is that what it be? What is it going to be based on? When you say the path forward, is it going to be the solutions for all the architects to read, or is it focused on one element only?
Well, the last one is just on everything outside the building, the site, the transportation, the infrastructure. And then we're going to go through and revise the documents. Right now, we're trying to hand off the series to a nonprofit.
Uh-huh.
So we came up with it as a private industry, but we realize our competitors are not eager to forward our website to to their clients and to other people in the industry. So the idea is we're going to try and hand it off to a nonprofit and then have it updated every 6 to 12 months with technical experts to make it kind of this evergreen, always the latest links, always about 4,000 words a post with great graphics. So it's becomes the industry resource, like an embodied carbon 10 or a carbon 101 that covers everything from why are we asking the question to the science of global warming to what do you do about interiors or structure or
Mhm.
MEP.
Okay, but I saw that on your website that there is one. It's episode 17, or that is the path forward, that I
Uh,
believe hasn't been published yet.
yeah,
Is
so
that right?
that's a plan for, yeah, that's our sustainable action plan and a kind of a path.
Okay.
Yeah, it's intended to be a summary of, because I realize that we're all drowning in resources, as I mentioned before, and a lot of people can't read a whole white paper, let alone 16, even 4,000 word white papers. So it'll attempt to be a summary of here's the 10 or 20 things we need to do as a profession. And the idea is that would be updated from time to time. So as we get good at a couple of those things, we bump a couple more on the list and bump those off the list.
Okay. So again, I think it's a brilliant document, and we'll be happy to share it. You said earlier that some NGOs. So anyway, we are happy to share all the documents. So we'll talk about my colleagues will get in touch to see how we can help with that. And I think it's one of the best series of documents I've read because they are super comprehensive, but easy to read as well. And as you said, with nice graphs, and it's and you touch on so many different topics that I think if I'm asked, and I've been asking the last few months or years to, what people that want to know about it. Actually, I have a friend that I have to send an email now. I'm going to send a link to your website because that's, I think, everything he needs is there. So congratulations again for that, and thank you for attending us today. And I hope more and more people take that approach and they share the work they do, because at the end of the day, the more we share, the more we can apply it to the work we do, and then we can lower and hopefully achieve that net zero that we are aiming for.
Yeah, thank you so much for having me on. And yeah, net zero, carbon neutral, whatever we come up with it. I look forward to what you come up with on that.
Okay, thank you very much. A pleasure.
Thanks. Bye.
Thank Thank you for staying. I forgot